Hey there. Today we are going to now move into how to apply matrices to systems of equations. And this is going to be the first of 2 days. We're going to look at two different systems for solving systems of equations. And we are going to use both 2x2s and 3x3s. So let's just dive right in. Matrices, as I said, we are using them to solve systems of equations. So for example, if we had this system of equations, this is something that in the past we would have solved with either graphing or substitution or elimination, but we are going to set it up with a matrix, and we're going to make it a matrix equation that looks like this. Now, my numbers are coming from the following places. The 1 is coming from the coefficient of x, 2 is the coefficient of y, 3 of x, 5 of y. So notice that the first column are my x coefficients, my y column are second column are the y coefficients. We have this little column here or little matrix here of x, y, and all that means is that these are the two variables we're solving for. You could put, if you're solving for a and b, you'd put in ab. It's just defining that those are the variables we're solving for. And then we've got 5, 14. So let's set one up ourselves. If we have this system of equations, we need to solve it. So when I set up this equation, I'm going to start with a matrix for the coefficients of x and y. And I do want to make sure that my x's and y's are in the right place, that it's x first, then y. And so I'm going to get 2, 1, 3, 2. My next matrix is just going to be defining the variables that we're solving for. We're solving for x and y. And then this equals 11, 6, the constants on the other side. It is important to also note that our equations have to be in standard form in order for this to work. Okay, so now this looks like the problems that we've been solving where I need to move this matrix on the left, 2, 3, 1, 2, I need to move it to the right. But in order to do that, what do I have to do? I have to find the inverse. So I'm going to find the inverse of this. The first thing that I do to find the inverse is to find the determinant. So for my determinant, I'm going to get 4 minus 3, because I did 2 times 2, minus 1 times 3. So this would just give me 1. So that means that when I do my inverse, I'm going to have 1 over 1 times, and now I'm going to switch the order of the ones on the main diagonal, although in this case with them being the same number, it looks like they don't change. And I'm going to change the sign of each of these numbers, -1, -3. Since it's just 1 over 1, that means that my inverse is the same. All right, now I can take that inverse and multiply it by 11, 6. So I'm going to have like this and like this. All right, when I do matrix multiplication, I'm going to get 2 times 11, which is 22, plus -3 times 11, which is -33. Oh, sorry, nope, -3 times 6, my bad, which would be -18. And then -1 times 11, which is -11, plus 2 times 6, which is 12. And this would just give me 4 and then 1. But what does this answer mean? It means that if I solve this system of equations and get the ordered pair where they cross, it's going to be that they cross at the point 4, 1. And I could check that with substitution or elimination. I could check it by plugging those points in to the system of equations. I could check it by plugging it into the matrix. But that is what this means, is that if I graph these two lines, they cross at the point 4, 1. Let's look at another problem. This one's going to be a little trickier because we have a system of 3 equations. So, but it's still possible to set this up. So what we're going to do is put all of our coefficients of x, y, and z into a matrix. And I do want to make sure that it's x, y, z, x, y, z, x, y, z. So I'm going to have 1, 1, 1. What do you think this second row is going to look like? It looks weird because there's no z, but it's going to end up looking like 2, 1, 0. Since there's no z, it's like having a coefficient of 0. And then we're going to have 1, 3, negative 3. And then my variables I'm solving for are x, y, and z, so that goes in the next matrix. And it's going to equal 2, 5, 14. Okay, now this is where we're going to use our calculators. So I'm going to jump over here. I've got a TI-89. We're going to use our calculators. You should have already watched the video on how to do inverses and determinants on a matrix. But what we're going to do is go ahead and just find the inverse. So when we're solving, you can just use your calculator to find the inverse and not have to find the determinant first. So what I'm going to do is I'm going to go to Apps, and I'm going to go to Data Matrix Editor. So it's 6, and I'm going to make a new matrix. I don't want this to be data, I want it to be a matrix, so I'm going to change that first option to matrix. I'm going to name my matrix, and I think I need the alpha on. So I'm going to name this, oh, no, it was already on. So, there we go. All right, so I named my matrix A. You can name it any letter, but it does need to be a letter. And I want this to be a three rows. Oops. There we go. I had hit enter too many times. So I've got a 3 by 3 matrix. So now I'm going to use what I had from my PowerPoint here. I'm going to put this matrix right here into my matrix in the calculator. So I've got 1, 1, 1, 2, 1, 0, and then 1, 3, and then I'm going to use the negative sign, negative 3. And now my matrix has been entered in my calculator, so I can click the home button. And this is where it gets really good, you guys. So I'm going to click the alpha button in A, because I named my matrix A. If you named it something else, you would put whatever letter you put. Like if you named it H, you would put H instead of A. And I'm going to use this little caret button to show an exponent. And I'm going to raise it to the negative first power, because we hopefully remember now that negative 1 as an exponent means inverse. And watch this. When I hit enter, it's going to think, and this is my inverse matrix. I bet you're glad I didn't make you find that without a calculator. All right, so I'm going to use that, and I'm going to come over here, and I'm going to say, all right, my inverse matrix, let's see, where do I want to, I'll put it up here. My inverse matrix is, oh no, I'll put it down here, is negative 3/4, or sorry, negative 3/8. Positive 3/4, and then negative 1/8. 3/4, negative 1/2, 1/4, 5/8, negative 1/4, and negative 1/8. Okay, so there's my inverse matrix. What do I need to do with the inverse matrix now to finish solving? I need to multiply it by this matrix here. So I'm going to multiply this by 2, 5, 14. And here's the even better news. I do not expect you to do that without a calculator. So I'm going to go back to my calculator. And I'm going to create a new matrix that would fit that third one. So we're going to have, it was a data matrix. All right, remember I got to change this to a matrix. I'm going to arrow down to variable, and I already used A, so I'm going to use something different. This time I'm going to call it B. I know, super crazy. And this one has 3 rows but only 1 column. 3 rows, 1 column. And it was 2, 5, 14. And so now I've got my 2 different matrices. And so when I go to home, I can actually, here's what I can do. I don't even have to retype that. I can just arrow over and it's there. And I'm going to say take the inverse times alpha b, enter, and it gives me my answer. How amazing is that? So when I go back here, I can say, all right, when I multiply these together, I get 5/4, 5/2, negative 7/4. And if you want to do what we did in the last lesson and find that by hand, you can. However, I'm giving you full permission to use your calculator on these. So this would mean that if I solved this, my ordered triple would be 5/4, 5/2, and negative 7/4. All right. Last one, write this system of equations as a matrix equation and then solve the system. So we are going to, on 2x2s, we're just going to kind of be in the habit of solving them by hand, and on 3x3s, using our calculator to solve them. So when I set this up, let's switch. This matrix, what is it going to look like? We should have 3, 5, 2, and negative 1. And then I'm going to have x, y, and equals 1, negative 8. All right, so there's your setup. I want you to find the inverse of the first matrix of 3, 5, 2, negative 1. And then I want you to go ahead and solve for x and y and see what you get. So pause the video and see what answers you get, and then come back and check your answers. All right, so you might not be very happy with me because I was making you work with fractions and work with things like 1/13 and 40/13. But if you did your work correctly and you check it along here, you see that we should actually end up with answers that are really nice, like -3 and 2. And we could check that by plugging these into the original problem to see if it makes a true statement. So I hope that you are kind of appreciating matrices and seeing what they can do for you and how they can help you keep your work organized. As always, if you have any questions, please let me know.